Hello, everybody, and welcome to another episode of Chips and Tips. I'm Justin Gray, the CTO of Toolpath, and with me here is Miguel Pinilla. Say hi, Miguel.
Hi everybody. This is Miguel Pinilla, and I'm the CTO of Arda Systems.
So besides being the CTO of Arda, why don't you tell us a little bit about yourself, your background?
Well, my background, I like to think of myself as a supply chain, logistics, and operations geek. Both in my academic career, I got all the way to a doctorate from Stanford on that topic, and I've dedicated my professional career to what I like to say, moving boxes, the flow of materials, and either big boxes, sometimes in container terminals. I was with Navis, which is the biggest software for container terminals out there in the world, or small boxes. I was the head of product in Dematic, and also at Keon Group, product strategy, and the R in R&D, which for me, being a geek of these things was a highlight, because you get to touch from fuel cells to cloud systems, all under one roof. So that's a quick summary of myself. I've been building systems for the better part of 25 years, including some of the very early software as a service warehouse management systems, which I built in 2005, 2006, Smartphone, that then got bought by the larger players, Red Prairie, now Blue Yonder, and so on. So that's a little bit of me, and I can be talking about these things in inappropriate lengths to the detriment of anybody listening. So,
well, the good news is we're here to nerd out on it. If your career is about moving boxes, I imagine you've had to deal with the knapsack problem and the bin packing problem quite a bit.
Mm-hmm.
Although containers seem to be a dirty hack to get around the bin packing problem. I guess you didn't pack into the containers, but yeah.
No, but it's more, the big challenge that I found consistently over, and I'd say moving boxes, but it's moving boxes and then fabrication and the operations in between, right? That fill the boxes is the big challenge, the challenge of packing and stuff like that. It's reasonably well understood. The big challenge is to have things arrive to where they need to be on time. And that is consistent across, no matter the size of the boxes. You need to get the container to the ship side when it's ready to be loaded. And you need to get the box to the loading dock when the e-commerce delivery van is ready to go. And that is the big thing, is to have things on time, shorter and shorter lead times, and so on. So that is where the challenges are.
Okay, well that fits very nicely into Arda and Kanban and making sure that the sourcing of stuff into a shop is sort of just in time.
Oh yeah.
Okay. Well, I think the challenge in manufacturing, like you said, is to fill boxes. So let's go a bit deep into what it takes to fill more boxes and fill them more quickly. My perspective is all based on job shop work. Before Toolpath, I worked at NASA, and I didn't have to fill any boxes.
You had to fill satellites, which is
I worked on the aircraft side of stuff, and it was all theoretical and R&D, so then I didn't have to fill boxes. We did some bin packing algorithms every once in a while, but that was as close as I got. But as a machinist and a job shop guy, the key challenge is always like getting your parts out the door on time. And so let's talk a little bit about like spindle runtime and how shop processes and like efficiency theory interacts with that. And also how robots and automation will play with that and affect that as well. So I'll lay out a scenario for you, and then we can just kind of talk through what kind of stuff you would expect a shop to think about there. So let's say I'm a two-man shop, me and a business partner. Let's say I have 4 machines, some 3-axis, some 5-axis, could be a lathe, the machine mix doesn't matter tremendously. But it's just me and one other person, and we've got to make a lot of parts with a lot of different materials all the time. This is pretty typical job shop stuff. And we're finding that we are just always right on the edge, either a little bit late or just in time. We're never early, and we can't imagine how we could possibly have more capacity. So even just adding a robot, right, so that I could get overnight running feels impossible because I'm already drowning in trying to get stuff through my shop. So what do I start to think about there? What's my metric? How do I find bottlenecks? How do I dig myself out of the hole?
So when I've seen these kinds of situations in shops, and take shops as an extended understanding, it include also e-commerce fulfillment centers. They're kind of shops, they manufacture boxes, right? We will fulfill with things, right? The challenge is not that it's not a spindle time in the sense of once a part is under the spindle, it's reasonably predictable, save to drill breaks and things like that, but it's reasonably predictable how many you're going to be getting in the next few hours, right? The challenge is, let me put it in from the other side. Your life would be much easier if on Monday, you know that you all the week was going to be dedicated to make blue counterclockwise widgets.
Blue counterclockwise widgets. Okay.
Yeah. So then you would set up your machines. You would get all the raw materials at the beginning, and then crunk, just making donuts, right? So the challenge is when you halfway through the week, you get an expedite order that breaks your flow,
right?
Or that, hey, even at the beginning of the week, you don't know exactly how many parts you're going to need of one thing or another, or you have uncertainty on when you're going to be receiving certain supplies, right? The problem is that any time that the machine is idle is time that you don't recover.
Okay.
Right? So the thing is, all right, look at what is the machine that is. I like to recommend this book, The Goal. Is kind of a North Star for this kind of thing. So yes, look at your machines and see which one has the most work orders piled up on the inbox, right? And then you will likely discover that machine not only has the most things piled up, but it probably has a fair amount of uncertainty in its operation.
Okay.
Right? So
it's a double whammy.
Right. So that because they're highly correlated. Things that have a lot of uncertainty tend to are a lot of variability. That's how people like to talk about it. How things that have a lot of variability tend to accumulate a lot of work, because as the moment that you lose time with something, you don't recover it, and then the inventory or the work in progress piles up. And the work in progress has a very nasty, not the work in progress, but the utilization of the machine has a very nasty characteristic, which is that as you ramp up your utilization of your machine, the delays that machine introduces are asymptotic. They grow to infinity.
Okay.
So if you are at, let's say, an 80% utilization of your machine, right? An error of plus minus 2% in your estimate of the capacity of the machine,
right,
is going to result in a minus 12 plus 25% swing in the time it takes any particular part to get through that machine. Like, how can this be? I mean, the machine is the same. I'm doing the same thing. It's just, but the queuing effect that that piles of the work that piles up ahead of the machine,
right,
it just swings wildly, and that is so that's why you never need to look at never. Utilization is good for to look at for financial metrics in terms of return on assets, but it's a complete disaster to focus on that for operational reasons.
Yeah, that's a pretty key topic. I know Chris Sabatini hammers on that quite a lot. OEE, or overall equipment efficiency, utilization, they're kind of the same thing. I think they're the same thing. And like a lot of larger shops will try to optimize for OEE or 100% utilization, and there's so many pitfalls there. The simplest and dumbest one is that your operators just turn the feed rate down to 50% to increase the OEE, which is like the exact opposite of what you want. But you hit on something really important there, and actually I'll draw a weird parallel to my personal life. As the CTO of a growing startup, I'm sure you can relate. I don't have enough hours in the day. And so I talk about how, as my personal margin, like the number of hours unallocated in a day tends towards zero, then like the effect of any kind of small disturbance in my life tends toward infinity. Yep. Which is what you were saying happens to the machines too. And I never drew that parallel. I feel that personally very deeply. And so I work to maintain certain margin. And for example, if Al Watmo, my CEO, comes in and says like, hey, I need you to take on this extra project, I'll look at like how much margin I have and be like, I can't do it. Like it would take me down to 5% margin. We're not doing that. Not that my personal schedule is that precise, but you get the idea.
Yeah. But it is truly the same effect. It's truly the same effect. And let's say that CTO tasks or knowledge worker tasks, they have more variability than a machine, right? Than a machine task. So that's the it is a compounding effect. Now you mentioned robots, right? So
well, hang on. Before we move on, I think I want to establish like a key thing for myself to write down, but also just for anybody listening. As you're looking to stabilize processes in your shop, it sounds like you should maintain a minimum unused spindle margin, right? Like whether that's 20 or 30%, but you shouldn't be aiming to like maximize your spindle uptime to 100% because you'll make your entire system unstable.
Yeah, and that is for sure. But if I have to give a recipe for this, right? Because people say, okay, yeah, of course, if you have your shop empty, then any single job is gonna go through quickly, but then you don't have a business, right? So what's the point, right? So the thing is not there is not a magic number of saying, okay, keep your utilization down and so on. The thing is, choose your control variable properly, and the control variable is not the utilization of the machine. Because the utilization of the machine is something for one, it's extremely fuzzy. You don't know. I mean, can you tell what the capacity of the machine is? For sure?
No.
It's impossible.
Right.
And if you cannot tell the capacity, you cannot tell the utilization. And if a 2% error in that estimate, it gives you swings of 10 to 30%. It's nuts. So the right control variable that you need to focus is how much work in process you have. How much?
Okay.
So
the size of the backlog, right? Okay.
The size of the backlog on that particular machine or on the shop as a whole. And limit that, and because you can play with that. You can say, okay, I'm going to increase it and see what happens, and I'm going to decrease it and see what happens. But the thing is, the swings in time that an error in your working process induces are linear with the amount of work in process.
Okay. All right. Right.
And that is a much better control variable. I mean, we're all nerds and engineers, so for us, controls, feedback control and so on. So if I see that my delivery times are creeping up, I can go and reduce the working process.
Okay. And you could do
Which is what you're
that by
saying.
quoting less work or increasing the number of people in the shop to move.
Yeah.
Okay. All right. I see.
Yeah.
That's an important point, that the effect of an error is linear with the size of the work in progress.
Yes.
But asymptotic with
asymptotic to infinity.
Right. To infinity with like your utilization.
Your utilization.
Right? Okay.
Yeah. So that is a key takeaway. The other thing is that you say, well, limiting work in progress. Hey, I don't want to reduce the demand because that's my revenue, right?
Right.
But even just reducing it on paper. I mean, there is a point. Everybody that manages a shop floor, and the bigger the shop floor, the more pronounced this effect is that there is a point where you release the work to the shop floor,
right?
And at that point, you are committed.
Yes.
It's really, really expensive to go and reorder things or pull something out of the shop, which may be halfway and so on. So the point that there is a point where you commit to a job.
Yeah,
right?
that happens in software too. The mirrors there, right? When you release the job into the sprint, and now the team has to, and if you want to stop the sprint, the correct accepted process is to like full halt the entire sprint and be like, okay, everybody clean up all their stuff. We're starting over. Yeah.
Yeah. Okay. And hey, software learned from manufacturing on that, which is the interesting part. Now we need to learn it back.
Right.
But then, so what it means is that if you reduce your released work in progress, you get a lot of the benefits, and then keep the rest of your work in progress in paper, because then you can reshuffle that paper.
Right.
Which is what you were telling your CEO. Hey, I cannot take on that job.
Right.
I cannot take on that task. Right.
Okay.
Or if it is really important, I say, okay, well, I'm going to take on that task. I'm going to swap it by this other one that is still on paper, and that's much cheaper to do.
Okay, so there's almost like there's two queues. There's the pre-shop queue and the shop floor queue, and the shop floor queue is the one that drives your variability very heavily there.
Yeah.
Okay, yeah. I like that. Okay.
Yeah.
So I stopped you before, but we were going to move on to robots. So an interesting discussion with robots that I've had recently is, so Toolpath provides a quoting software. It automatically analyzes your part and helps you figure out runtime. And runtime is typically very critical for people quoting parts. Yeah. Now, if you're doing production work, it's obvious why the runtime, right? Like, because you know how many parts per day you can make, do changeover, all of that stuff. But most of our customers are job shops doing, 1, 2, 3, 10 parts. And it's interesting because, like, at least theoretically, runtime should be almost irrelevant for them. Not completely irrelevant, and certainly it affects cost for harder materials. Like if you're, if you're cutting an hour's worth of steel, then you have to replace carbide and things like that. Yeah. But irrelevant in the sense that most shops have essentially infinite spindle capacity if they have a robot. Like if there was this magic thing where the robot could just load the stock and load the tools, most shops are not running spindles 24/7, right? And they're there 8, 9, 10 hours a day. They basically have all this unused time if they have a robot. But if you don't have a robot, all of a sudden runtime becomes important, not because of its effect on cost, but it affects like how long you personally have to stand in front of the machine swapping parts out. Yeah. So the effect of automation there, like, I don't know, for me, it changes the bottleneck. It changes the way you think about pricing out work, kind of fundamentally, or at least it should, I think.
Yeah. Well, for me, a robot does two things at the let's call it at the flow level, right?
Right.
One is reduces overall variability of the operation.
Right. Okay. Yeah.
Right. Because the part doesn't need to be waiting for an operator to show up to load it.
Right.
Right.
Yeah.
So then the variability of a part from the moment it shows up in the inbound discharge or in induct until it shoots out on the discharge on the other end, it's less variable, right?
Yeah.
And variability is evil, as we would just discuss, right? Because it gives you those asymptotic behaviors and stuff like that, right? So that's one of the main benefits of having a dedicated robot to load and unload parts is that you reduce the variability of that cell.
Okay.
Right?
Yeah.
The other one is because then you don't have a spindle or you don't have a CNC anymore. You have a cell.
Right.
So your unit of planning should not be the CNC, should be the cell at that point. Right. Which is another way of looking at it if you want. But those are the two things that you're gonna see, right? When you introduce a robot. There are other, if not as hard operational science or operational research aspects, right? So if you start introducing robots in your operation, your workforce is gonna switch.
Okay,
it's gonna change.
Yeah,
it's gonna switch from manual operation to more automated operation. The profile of the people that you're gonna hire and that you're gonna have is different. That's for one.
Right.
But
yeah,
also,
I forget who was saying it, but somebody recently said, "Oh, I bought a robot, and now instead of a CNC operator, I have to have like a very expensive robot applications engineer on staff." Yeah,
that's right. That's right. And that's one. Second, your accounting is switching.
Okay.
And it may be something that from the operations point of view you're not paying attention to, but if you are in the a few people job shop, all of a sudden your direct costs are going to go down.
Right.
And your indirect costs are going to go up.
Okay, right. More capital expenditure, right.
More capital expenditure. And the salaries of those people, the salaries of the applications engineer, you cannot, you need to start doing allocation.
Right.
And then doing allocation brings its own, doing allocation accounting and cost allocation accounting brings its own evils if you're not careful. Because all of a sudden it may be distorting the profitability of your different parts.
Right.
And you need to be paying attention to that. When you introduce automation, you need to introduce automation and in partnership with your HR department, whether you have it or not, or whether it's your other part of your brain, right? With your HR part and your with your CFO. It's like, hey, how are we going to know which products are profitable now or not? Because all of a sudden, we are if we're not careful, we'll be spreading peanut butter across all the products of these indirect costs, right?
Right. You can bury a lot of costs that way. Yeah.
Right. So you need to be careful with that. And then when you introduce automation, this is the other effect on operations is that you are going to be reducing the flexibility of your shop, right? So that's it. With newer robots, the ones that they're self-learning and all these kind of things. So there is all these fancy things that you read on the trade press. That is happening less, right? But no matter what, the flexibility of your shop is going to be reduced, and your ability to take marginal jobs that may fill some holes in your schedule is gonna be diminished. So those are things to consider when you are looking at introducing these highly automated systems.
That flexibility is interesting. I'd never thought of that, but I mean, we can see a progression of that between part loading versus pallet loading. Yeah. Pallet loading is an attempt to buy more flexibility in the robot. But even there, everybody's had a job that like exceeds the limits of what their pallet could do, but the machine could have done it. They could have snuck it in, right? And so if you're looking at your business model and you're like, well, my day-to-day jobs, those are the ones that, keep the lights on. But at once every 6 months, I get this marginal job that just I squeak onto the machine, but I make a ton of money off of it. The robot may put that at risk. So that's interesting.
Yep. And when you couple this, and this is when you couple those effects with the way and the assumptions that are built into, let's call it traditional or legacy ERPs, you need to be real careful, because you really may end up in a hole real quickly.
Okay.
Right.
Interesting. The ERP somehow makes that worse.
Yeah, because think of the assumptions. That for one, it makes cost allocation seemingly simple, and it's true. It makes it simple, right? But simple things should not lead to unexamined things, right?
Right.
Because something is easy. You can set it up and then off you go, right? And then all of a sudden you see the monthly reports, and then your profitability of the different parts is not clear, or of the different products and stuff like that. And you need to know how you're setting it up. That's on the financial side. Because making it easy, it may give you let's call it an excuse to not think it through. But the more insidious one is the assumptions it makes about production. When you run your MRP, when you run your production planning in an ERP, the assumptions that it's making is, well, for one, you put in the capacity of your shop, right? Of course, because everybody has wisened up. The capacity of your shop that you put in the ERP is way below what the shop can actually do. Right. Because if you don't, you're going to end up with chaos. On the shop.
That's compensating for margin, right? Okay, yep.
It's giving a safety margin so that if things go wrong, because things go wrong, things change. And you also want to keep a spare capacity for expedited orders from good customers and all these kind of things, right? So, but ERPs think they say, okay, I got the orders and the forecast, and I do the planning, and then assign the tasks, release them to the shop, and my job is done.
Right. No plan survives first contact with the enemy. Yeah.
Exactly. Right. So when you put that, when then you put that on a shop that you have reduced flexibility because you have introduced automation carelessly, or you've gotten carried away by it. Right. And I made my living out of automation. I mean, don't take me wrong. I mean, the Matic automated probably half the Amazon warehouses in the US. So, but when you couple those two things, that you have reduced flexibility, meaning a reduced ability to react to unexpected conditions, right. With an ERP that thinks that its job is done once it releases the jobs to the shop, that is like trouble. That spells trouble.
Sure. Yeah. There's like a disconnect in communication. Okay, let's back it up, because I want to make sure I connect the dots properly here. So if we go all the way back to the beginning, we talked about how it all seems to come back to variability, but the effect of uncertainty on the process is linear with the size of your in-process work, right? And so to make your shop more stable, you should shrink that in-process work queue, right? And that goes to Toyota Production System and One Piece Flow. All of those things basically say, like, keep the amount of work as small in process as small as possible. Don't make big batches. Don't have 7 jobs in process at once that you're trying to juggle. Do one job, get that job completely done and through the system, and then do the next job. Obviously that, right, that sounds like you're reducing your revenue because you're doing less work at a time, but the Toyota Production System and Lean and all of those things are talking about how shrinking that in-process queue lets you then focus on making that velocity of things through the queue as fast as possible, right? So I'm a good shop, and I've started shrinking my in process queue. I'm backing it up more into my my paper queue, we'll call it. And I've started focusing on improving the process and getting, lean into a production system. And my velocity is starting to pick up. I'm feeling pretty good about this. And so now I go and I buy a robot. But now this robot needs to be busy 24/7. This is an expensive piece of capital that I bought. And so my instinct is to increase the amount of work I release to the shop floor again so that the robot can start making chips, which is like the opposite of how you stabilize your system. And then on top of it, to make another reference to my old life, I used to joke that an optimizer is a piece of software that automatically finds every bug in your model for you and exploits it. And a robot is essentially the same thing for the shop floor. It's a very expensive piece of hardware. It's a very expensive consultant that will find every single weakness in your job process that you haven't yet fixed. And so you buy this piece of capital, and so now you have more spindle time effectively, right? You don't have to be standing in front of the machine. And so you want to release more work to that robot to get it through, to have it go. Right? So effectively, the tendency would be to queue up 5, 6, 7 jobs on that robot. But that's the exact opposite process for how you want to think about that. You still want to keep that work queued down, and you only want to release things to the robot. You want to make sure the parts are flowing through the robot as fast as possible, because you're trying, you don't want the robot to be making like 10 parts. I guess the version of this is people say is like the robot's the fastest way to make scrap there is, right? So
yes, and automation is the fastest way of producing crap. But I have a slightly different view on that, right?
Okay.
So think of again, appealing to our shared engineering background, right? See what your Kanban system, let's say that you're running a Kanban system. What your Kanban system is really, really doing is providing a feedback signal from downstream to upstream in terms of congestion. It's a congestion signal.
Okay.
Right?
Okay.
And then you determine, okay, in this Kanban loop, I'm gonna have 10 cards, right? So I know my whip is beautiful. There's only 10 and always 10, right? Or 10 or maybe a few less while somebody's producing or stuff like that, right? But 10 plus minus 2, that's it. Very well controlled, right? And then the thing is running. Then you put a robot, right? And all of a sudden, but you still have the 10, right? So now the robot is twiddling his mechanical thumbs, right? A lot of the time, it's like, what the hell is happening here, right? So the trick, when you're saying you release more work to the robot, what in a Kanban system, what is it that what does that mean in reality? What that means in reality is that you need to put more cards in that loop.
Okay.
Right?
Okay.
So you're going to say, okay, I have 10 cards. Now I'm going to put 20 cards or 15 cards in that loop, right?
Okay.
Which is what we were saying before. And you are still safe because your delays are going to be proportional. So if you put 15 cards, you know that your delay is going to be, your end-to-end delay is going to roughly be 50% higher, right?
Right.
Than with 10. But because you've introduced the robot, your delays have gone down, right? So you put more cards, your release goes up, right?
Okay.
So, all right. So, but what you're doing there is, if the Kanban is your inner real-time control system, what you're putting is a management control system on top.
Okay.
What you're observing is how fast what is my lead time from beginning to end of this operation?
Right.
And that's your control variable. And you can measure that with a clock. You put a red sticker in one part, click when you put it in the queue, and when it comes out on the other end, click, right? You know how long it is. Right. So that's your control variable. And what is your control? That's your observation variable. What is your control variable? The number of cards in the system.
Okay. All right.
Right? So it's not like, okay, I want to minimize the work in progress, meaning the number of cards circulating to the lowest possible. No, I want to have I want to right size that. And it may change over time.
Right.
Because the product mix may change, the conditions in the spindle. On Tuesday, Joe is going slower because he was sick the day before.
Right.
Whatever things
Joe's always
change.
sick.
Yeah, Joe is sick, and Jill is distracted. Right. It's kind of so. Those kinds of things happen. So at that point, your Kanban loop can control the variability on the real-time sort thing. Keeps your system stable. But it may keep your system stable not at the control point where you want.
Right.
To put it at the control point that you want, you need to put the outer management loop of observing your lead time and say, okay, my lead time is excellent, is so excellent that I have too much slack here. I don't need to produce things so that they stay on the staging, on the loading on the shelf for 2 days. So I'm gonna add more cards.
Right. I'm gonna make other things. Right.
I'm gonna make other things. Right. But again, your control there is the amount of work in progress inventory, the number of cards that you have.
Okay, I'm going to circle back and try and talk this through again because, first of all, this is a new way of thinking about it for me, which is really cool. But also, I'm going to make an attempt to translate into context that machinists will understand. So we start out, we have a shop. They want to make stuff. We don't care about spindle uptime. Like that's a measure. That's a thing you can measure, and like it's a problem. It's a problem for the system if that number starts getting too high. Because that creates like rigidity or not rigidity, fragility to variance, right? But we want to take on more jobs. And so the very first thing we need to do is reduce the size of the in-process queue and focus on getting things through the system faster. And then that's a real-time loop, and you can use Kanban or Toyota production system, right? To try and improve that system, lean, those are all those things. And then as you get better at doing one job, the next job, your effective capacity goes up because the time of your loops got shrunk. And so you can afford to do more loops in a day. So now you can start not increasing the size of your work in progress queue, but running things through that queue faster and faster. And so you can just do more loops in the day, and that lets you get more progress. And now you get really good at that. And so you feel ready to introduce a robot. And the instant reaction to introducing a robot is, obviously it increases more capacity. So effectively it buys more hours in the day, right? So instead of one shift, you can run 3 shifts. And so, at a very, very simplistic view, machine plus robot should equal 3x the output. But one, you may not need to make 3x the parts. So like there may be a limit to how many iterations of the loop you need to do. And 2, the other challenge is that you've introduced a new physical thing into your real world system that may break it and may make it more variable, more unstable. And so before you start trying to increase the number of loops, you have to go back and remeasure the length of your Kanban loop now, the length of time it takes, and start readdressing those bottlenecks. And then that lets you, it's like an S curve kind of, right? Although in a sense, it might be like a downward S. Like the robot may initially hurt your productivity, and then you have to work to get it back up to where it was. And then once you get it back up to where it was and it's very stable, then you can have it. It may not even, like, the size of your loop may be even a little slower because, like you said, the robot is more stable, but maybe not as fast. But now, okay, I'm a little slower, but now I've restabilized the process. So I can start extending the number of iterations I do during the day. I can start doing 2 shifts instead of 1, and then 3 shifts instead of 2.
Certainly, that is a straight extension of capacity. But you can, if you have, remember, automation well managed reduces the variability of your operation, right? reducing the variability is going to reduce your lead times.
Right. Okay.
And when you reduce your lead times, that gives you a slack to play with. And then you need to decide how you're going to use that slack. You can use that slack to promise more aggressive delivery dates to your customers. You can use that slack to increase your throughput, knowing that increasing your throughput is going to start creeping up the utilization and stuff like that. But if you do that, controlling your work in progress, you are still safe. You are still in control. Right?
Yeah.
So you take that slack and then you allocate it to what your business objectives are, right? And then what this dual control loops, the Kanban and the outer one of controlling how many cards you put in the Kanban, or their equivalent like Conwhip, and there are other ways of doing that, or the drum buffer rope. And there are several things that are out there that you can look at. But this outer one is the one that controls the parameters of the control of the inner control. Right. So the beauty of that is that it gives you the decision power, and if you see that at the beginning, okay, while you are onboarding the robot, maybe things go slower. Well, things go slower, that you're going to start seeing it, that cards accumulate in one place or another, that your lead times start going up. Right. And then you can take a corrective action.
Right.
If you want. I mean, in software development, I tell one thing to the working with engineers, like I tell them, let's do stupid things only on purpose.
Let's do stupid things only on purpose. Okay.
That's right. So meaning that, you may decide to do something that is stupid, like taking a shortcut that you know that is going to give you trouble 2 months from now or something. But if you do that on purpose because there is a good business reason, because you want to launch something, if you do that because you have it thought through, that is perfectly acceptable. You are making business decisions for your operation. What needs to be avoided at all cost is to be surprised. Oh shit, where is my lead time?
Right.
My lead time is 3 times what it used to be. What on earth has happened? Right. So that is stupid. That is doing stupid things without knowing.
Yeah. You can't be a frog getting boiled slowly. Right.
Right. And what these mechanisms, apart from all the benefits that you read and so on, I think the Kanban and this other outer loop of control give you is the visibility and the ability to react quickly to changes in conditions, in business conditions, in operational conditions, Joe getting a cold or whatever, right? That is the main thing, because you may get the number of Kanbans wrong. I mean, you do your calculations, you get you put 10 cards, and all of a sudden you're not shipping product enough or something. Well, it's okay. Then you know, but if you're observing, then okay, well, the outer loop's like, okay, I'm going to increase the number of cards.
Yeah.
Right? Oh, now I'm shipping enough product, but it's taking too long. Okay, I do too much. Dial it down. Right? It's having the hand on the adjustment knob and looking at it like that, right?
Okay.
And that's something that, again, going back to my favorite boogeyman, that conventional ERPs don't do, because they don't have the ability to read the shop.
They're open loop. Yeah.
They're open loop. They don't read the shop. Right? They don't. And so that's kind of the takeaway, if there is one.
Okay. I think there's, at least for me, some key insight there into how automation works, and that you need to pay attention very carefully to the variability that it introduces, and make sure, right? In theory, automation should reduce variability, which decreases lead times. But you better be sure that it's actually doing that, right? Before you start trying to exploit the increased capacity that it should bring, you should make sure that it actually did reduce variability.
Yeah. And even, I mean, this is a second order effect, but the variability automation does a funny thing to variability. It reduces day-to-day variability, right? I mean, you see it working and it just works, cha-ching. But it introduces these bigger kind of black swan events, right? That when the robot goes down, you may be out for 2 days.
Right.
Because nobody really knows, oh my God, how do we put this back online? It takes forever. You need to call ABB, like, okay, there's a lot, blah, 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 that kind of thing. So it reduces variability, small v variability, but if you're not careful, it can increase the big V variability of shutting down your system.
Right.
Right.
Let me try that a different way. It's like building a freeway. And so now all of a sudden a bigger freeway, there's more cars on the freeway. And most days that means everybody's getting to work better. But then people, more cars are on the freeway. And so now there's an accident. And all of a sudden, way more people are affected by that accident. And so if you have a robot in your shop and you've loaded it up with parts for the night and everything's going and the Kanban loop's going and you're used to showing up and being able to ship 50 parts in the morning, the problem is like you don't have the ability to go catch up from the fact that the robot shut down last night, broken, and now you have 50 parts you can't make. You can only make 7 or 10 or 15 parts that day. And so your speed without that robot is really broken. And you may not even have any processes to operate without that robot anymore. And so like your risk, so you almost need like a backup robot or something. Yeah. I mean, it's the same as having 2 spindles, right? Nobody's comfortable with 1 spindle.
Yes. Yeah. That's this more integrated systems, and you and also with automation, you tend to eliminate buffers.
Right.
Which is good. In general, that is good. But when you eliminate a buffer, that means that you are coupling two pieces of equipment to each other. And if one of them breaks, the other one goes down. You don't have any wiggle room there.
Right.
Yeah. So there are those effects that that's not to say that automation is evil, not quite the contrary, right? And modern automation that introduces flexibility and so on. Like, for example, there is a big difference between traditional warehouses or factories with conveyor belts for distribution of parts to the new automated mobile robots.
The ones that like pick up the whole shelf and move it around.
Right.
Yeah.
Those ones, or they're small, like nightstand size things that carry 3, 4, 5 bins of parts around, right? If you have a fleet of 20 of those things, if one goes down,
no big deal.
Right? If you have 20 segments of conveyor connected, one goes down, your whole system is down.
Right. Okay. So one is more robust than the other, right?
Right. They tend, more flexible automation is more robust. So those things are, and that's software is doing wonders for that, right? Of this more flexible automation. Yeah.
Okay. The most classic case I can think of, and I'm sure you'll have 5,000 more, but I'm going to throw this one out there just to see what you think about it. I have a Model 3, a Tesla Model 3. When they built that line, Elon Musk over-automated the line and caused like huge production backlogs. And so they had to walk it back, and he had to go out and say, like, actually, people are better at doing certain things than robots. I think the example I heard that he talked about was there's this, like, in the battery pack, there's some like fluffy layer of insulation that goes in the battery pack. It's like robots can't, like a person can lay that down fine, but robots can't do it. And so they had all this trouble getting the Model 3 production line out because he insisted that everything be automated right from the start. And then they had to back all that off, put people on the line. And so I think there's a lesson there in robustness. Like, I think they didn't have robust automation, so they just tried automation.
Yeah, that bring up cars and so on. Let me give you another analogy with cars and whatnot to see what path the automation is taking. I could make a claim that, and it's a facetious claim, but that we are all enjoying since probably 50 or 60 years ago, automated driving.
Okay.
Self-driving.
Cruise control. All right.
Yeah. Well, cruise control, and not even that. Elevators.
Okay. Elevators. All right.
You walk into an elevator and you press a button and the thing knows where to go, where to stop, doesn't collide with anything, doesn't collide with other elevators and stuff like that. Right?
Yes.
So what's happening here? Like, okay, well, Miguel just said a stupid thing. Well, but if you abstract it a little bit, or if you look at it from a distance and squint, what you're saying is that to have successful automation, you need to have a combination of controlling the environment and automation smarts.
Okay. Right.
Right?
So less controlled the environment, the more intelligent the automation has to be. Yeah.
That's right.
Right.
That's right. So if you want a car that can drive in any circumstance, it has to be a really smart car.
Right.
If you want a robot that can lay down a squishy thing that flops around and so on, like what you were describing, right? You need a really, really smart and dexterous robot.
Right.
Right. But if you are moving a chassis from one place to another, a pretty dumb thing will do. Right.
Right. Okay.
So now take that thinking of, okay, well, environment or smarts, right? And then you can see how the different technologies apply to the processes that you have in your shop.
Right.
And you're looking at your shop, you can look at it. There is a way to look at processes call it a process spectrum. It's in two variables. I'm an engineer, so I need a whiteboard very quickly. So you can look at it either how much variability you have in a process.
Sure.
Versus how much volume you're doing.
Sure. And there's a Pareto frontier there, right?
Yeah. Well, in one end, you have a bespoke tailor, right? On the other end, you have Sarah producing fast fashion,
right?
All the same, right? Or even further, you have a paper mill, just producing chicken rolls of paper, right?
Right.
You're gonna fall somewhere there, right? And the state of the art of automation is, if you adjust the scale, right? Let's say it's on the diagonal of that.
Okay.
Right. So either you need manual processes for very high variability, low volume things, right? Or you have very environment control for things that have very low variability,
right,
with high volume, right?
Okay.
And in between is you find the right technologies there. And what automation technology is doing is pushing that diagonal up,
right,
to the right.
Right.
So you can see these flexible robots and the things that you see on the news of the anthropomorphic robots, which that's a different story there.
Right.
But things that learn and so on, that are saying, well, look, now we can automate things that have more variability, meaning I can bring those to higher volumes, right? So you're pushing the boundary that automation technology pushes the boundary of that diagonal to the upper right.
Right.
Yeah. And you need to know where you are in that spectrum and whether the current state of the art is applicable to you. Because if not, you're going to end up in a Model 3 disaster.
So if I translate that back to the shop floor, the most, well, not the most, but some of the most complex automation is part loading because there's the most variability there. And you're putting more variables in the way of the robot, chip clearance, making sure the vise is properly tightened, variation in the stock that can't be handled by some operator kicking out a bad piece of stock. Versus pallet loading, which is the robot is much, much simpler. and potentially more capable. Typically, pallet loading systems can handle more weight. The robot doesn't have to be as complex. But you're trading flexibility for that robustness. Has to fit on a pallet. You have to spend more money on the pallets. The pallet has a more constrained situation, and you may not have as many pallets, right, as you can do parts.
And spending money on the pallet and the fixtures for the pallet and all these kind of things. What it means is that you can only make that investment if you have enough volume,
right,
to justify it. Right. So that again, in that curve, it moves you. So you are reducing variability, but you're requiring more volume.
Right.
If you only have one part a month that requires that particular pallet, you are not going to do that.
Right. Yeah.
Right. So that's that is the thing there. There was another thought rattling on my head, prompted by what you said.
It'll come back to you. Variability seems to be what drives how you view all of automation then. Like your entire job is reducing variability in the system, controlling for variation. And then once you've got that under control, once you've brought that under a threshold, then you can start to change things in the system. And I think that's like a pretty critical point. Some people will ask, like, what does it take to bring automation into my shop? Or I'm an AI company. Toolpath is an AI company. Now they'll say, what does it take to bring AI into my shop? And I often say the same things that it takes to bring automation into your shop. You need to improve your processes. You need to improve your robustness. You need to invest in the right things that reduce variability, whether that's better work holding or better tooling. Make sure you're not shoveling chips out of your machine by hand, get a chip conveyor, et cetera, et cetera. When you've got all of those things dialed in, when you've got all of that driven down to a level that you're happy with, then you can introduce automation, whether that automation is physical automation with a robot or AI, right?
And AI is, what it's giving us is really, really flexible agents for that automation. Right? That their AI-based systems degrade on the edges way more gracefully than traditional systems. Right? And so they have a much broader tolerance to variability of inputs and variability of their environment. And I think that is a big promise, understated promise of the kind of work that you guys are doing.
So I guess what I've learned today, I want to bring it all the way back again, is one, besides just reducing variability, like the reason OEE is such a bad metric, like intuitively, or at least I think broadly, it's understood that overall equipment efficiency isn't a great metric to measure things for a whole bunch of reasons. Like your operators will just turn the feed rate down to increase OEE, which is the opposite of what you want. And what you really care about is how many parts are you getting out the door? Like, what's your revenue? What's your top line number? But you've introduced a new idea to me, which is that not only is OEE the wrong metric to measure, but optimizing it toward 100% is like the worst idea ever, because it makes your system unstable to any kind of variability. And it's exponentially asymptotically unstable. So the higher you drive OEE, the worse your system will react. And I guess we saw like the net effect of that during like COVID with the auto manufacturers, a lot of the supply chain stuff. They were driving toward higher and higher OEE, and then they got smacked in the face really hard. Where Toyota managed to keep that more under control, have buffers in the system where they felt like they needed it, so they didn't get hit as hard.
Go ahead. Absolutely. It's not that, hey, drive to 100% at your own risk, right? But it's again, the car analogies are helpful because we all understand them. The risk of accident, if everybody were to drive at 20 miles an hour, would be minimal.
Right?
Yes. Of course, nobody wants to.
Nobody's driving 20 on the highway.
Right. Nobody wants to do that, right? But again, if everybody was driving 160 miles an hour, then we would have a problem, we would have a lot of accident, right? So the key here is watch it, right? Don't blindly optimize to OEE or blindly optimize to the thing. Like, watch it based on your business parameters, and your business parameters are production and lead time. And lead time more and more important these days because the way that
Amazon has made everybody impatient.
Yeah, I mean, I used to call it in the book. I call it the tyranny of now.
Okay.
Right, the tyranny of now, that people you click and you get up from your seat to see if it is at the door. Right, it's like everybody needs to be on their toes, and that pressure is started on the distribution networks, and it's back pressurizing the whole supply chain all the way to manufacturers and overseas. So yeah.
Okay, so if I'm a shop or a manufacturing space and I want to start walking my way toward automation, I'm going to stop paying attention to OE unless my OE is too high, in which case I need to fix that first. Then I need to start looking at the amount of work that I have on the floor, and how much variability I have in my system. And I need to balance those two numbers to a point where I'm happy with. That's the outer control loop. And then once I get to a point where I'm happy with that, where I think my inner loop, my Kanban loop is working well, and I've optimized that to be as fast as I can, or at least done enough optimization that I feel like I've captured the low-hanging fruit there. Then I can start to bring automation in, whether that's automation on the quoting side, which allows me to start taking on more work because now I have more throughput, or whether that's automation on the manufacturing side, adding a robot, or adding more staff, or adding another spindle. And the way you make that decision is by deciding, okay, do I need more work on the floor at the time? So do I need a bigger number of Kanban cards on the floor right now? Or is my speed such that if I could run more loops in a day, that would be the better solution? And if I need a bigger amount of work on the floor at a time, then I might have to consider buying another spindle, right? But if I can afford to stretch that out overnight, then I can afford to buy a robot. And in general, if all else was equal and you were looking at those two options, the robot is the better option because it reduces variability, where adding the extra spindle requires another person or one person to run two machines. So even if the math says the two are equal, you're better off with the robot than with adding another spindle because the robot will reduce variability and the other spindle will increase it.
Both may reduce variability, but the robot has more potential to reducing that variability because you are, if properly managed, again, you are taking out a lot of sources of variability in one shot. I mean, the fact that distraction from operators are distracted, or if somebody's changing a broken drill, and an unrelated thing, an unrelated machine is stopped because it needs loading and stuff like that. You are taking out all those sources of variability. So that is true. When you introduce another spindle or another CNC machine, you may reduce variability because of the pooling effect, right? That if you have two cashiers, that you can balance the queues, right? At the supermarket, but it's less. Is less so, and as you rightly point out, you have another drill that will break, right? And then your operator is going to be distracted with that one, and it's going to create a bottleneck on the other one. So, yes.
Okay, so the answer is an extra machine and two robots. That's the answer.
Well, yeah, and then do that. Looking at. In terms of how much or what kind of automation is, look at that balance between how much you can control your environment versus how smart the automation available is, right?
So everything has to grow in balance with each other. Don't optimize your system for velocity only to find out that it's unstable, and now all that velocity backs up in the form of like unanswered orders and things like that. Okay, well, you've given me
control loops.
Yeah, control loops, right? Yeah, make sure that those control loops don't break down. They're not subject to like single points of failure. you have given me a ton to think through here. I think I need to digest it, and then we need to come back and try again.
We'll do that. As I said, I'm a geek of these things, and I love to talk about them and talk about the different pieces, either the software to control them or the operations and these things. So, yeah,
okay, I think on the next one, we'll have to talk a little bit about how the Kanban loop acts as a closed loop control on the shop. I've heard people talk about that before, but I've never quite understood it. So I think that'll be our next topic.
Oh, yeah, absolutely. Yeah, it'll be a pleasure.
Okay. Well, thanks so much, Miguel. I really appreciate it.
Thank you, Justin.
Where can people find the Arda stuff? They can go to arda.cards, right?
Yeah, arda.cards. Yeah, that's the place.
Okay.
Where we live. So, yeah.
Well, thanks again.
And also Uriel, co-founder, has also a very practical, very clear podcast on details on how to set up things and so on. So yeah.
Right, incremental. The podcast incremental.
Yes.
Yeah, I really enjoy.
So you can also find us there. Yeah.
Okay, so on incremental the podcast and arda.cards.
Yeah. All right.
All right. Thanks so much.
Thank you so much. Take care.